On-load release gear allows the lifeboat to be released with load on the hooks. It was introduced to overcome the problems of the old off-load system, which only permitted release when the fall wires were slack. Although a number of systems are in use, they all have the same common elements. The hook units, connected by push-pull cables to the control unit at the helmsman's position, and a hydrostatic unit, which guards against premature release before the lifeboat has become waterborne. Each hook is mounted between side plates, allowing it to move between the locked and open positions. Two basic methods are used to retain the hook in the locked position: cam-type systems and the open-topped cone. The most common system in the UK offshore industry is the cam-type, of which the Titan is the most frequently used, followed by the Tor design. We will be using the twin-fall Titan system to illustrate very important safety issues. Although many of the principles and problems are common to all gears, it is essential that you are fully conversant with the particular system that you will be working with. The Titan hook is retained in the locked position by the overlap between the flat on the tail of the hook and the flat cam pin face. This flat is produced by machining the pin in way of the hook to produce a D-shaped cross-section. The cam pin's position is controlled by push-pull cable. At the control unit, the cables are attached to quadrants mounted on a common shaft at the base of the main release handle. A hydrostatic locking lever is visible through the clear panel on the control unit. When it is in the green or locked position, it prevents rotation of the quadrants. Once the lifeboat is afloat, the pressure of water entering the hydrostatic unit deflects a diaphragm. This movement is transferred by a push-pull cable, which rotates the locking lever into the red or open zone, so allowing the quadrants to move. The control unit is also fitted with a safety pin, which must be removed before the handle can finally be operated. So, in normal circumstances, the system works like this. The craft is lowered into the water so that the hydrostatic locking lever moves into the red zone. The safety pin is removed and the main release handle is lifted clear of the slots and pulled back as far as it will travel, releasing both hooks simultaneously. If the craft is waterborne, but the hydrostatic unit fails to release the lock, it can be overridden by using the safety pin to break the clear panel, and then manually lifting the locking lever into the red zone. The same procedure could be used to release the craft if it has failed to become waterborne. This could be very dangerous, as it will release the boat at any time, so it should never be done as part of a drill. Even in an extreme emergency, such action must be considered only as the ultimate last chance of escape. You should be fully aware that it may result in serious damage to the craft and fatal injuries to personnel. Following a release, the system should be reset as soon as is practically possible. First, the main release handle must be returned to the locked position above the slots. It will not drop back into the side plates as the quadrants are still in the open condition. At each hook unit, the hook is rotated so that the tail is behind the cam. The small recocking levers are lifted upwards against the stops, rotating the cam into the flat-to-flat locked position. Resetting the hooks moves the quadrants on the control unit to a position where the handle and locking bars can drop down fully into the slots. Before inserting the safety pin, pull the tail of the hook against the cam face to check that a flat-to-flat contact exists. It is good practice to have this checked by a third party, as it is crucial to the system's safety.